All right, welcome to the follow-up to the follow-up to the original for part A here. I just, hopefully as quickly as possible, wanted to touch on another method that you could have done, okay? Taking the keystones, I guess you got to be hopefully as versatile as possible and be able to utilize all kinds of different strategies. And once you have this system written down, and again, x plus y equals 8 and 3x plus 5y equals 36. Another method you could have done just to solve this is basically what people call guessing and checking. So keeping in mind that ultimately, when we're trying to solve this, we're just trying to figure out what pair of numbers that you could plug in for x and y. So one number would be designated to plug in for x, and the other number in the pair would be designated to plug in for y. And it'd be like a pair of numbers that plugs in to make both of these equations true. And so you can do that by just guessing and checking. So I think it makes a lot of sense if you're going to start just kind of like randomly guessing pairs of numbers that solve both of these equations. We should probably start here, because I don't think it's difficult to think of two numbers that could plug in for x and y where x plus y actually did equal 8. And let's face it, there's not that many possibilities, in the grand scheme of things, there's really not that many possibilities to even check. So one of them that you might sort of think of first perhaps is, well, 4 plus 4 equals 8. If I plug in 4 for x and 4 for y, that would satisfy the first equation. But the question is, does it satisfy this one as well? So if you wanted to literally write it down, well, what if x were to equal 4, and what if y were to actually equal 4? Does that actually equal 36? Well, it doesn't take long to figure that that's 12. And that's 20. So is 12 plus 20 equal to 36? Nope. And so my first guess didn't really work out. And then you might move on to something, I don't know, you might go, well, what about 5 and 3? That definitely satisfies the first equation. But if I did 3 times 5 plus 5 times 3, does that equal 36? That'd be 15. That'd be another 15. That does not add up to 36. So turns out that my second guess failed. And look, it's worth pointing out right now that when you do guessing and checking, I'm not saying it's not a valid method, because hey, if it works, it works. Guessing, I have no big problem with guessing and checking, but sometimes you might have to do a lot of guessing and checking before you fall upon and almost randomly sometimes just sort of pick the actual correct answer. So I don't know. I believe the actual correct answer was supposed to be what? 2, 6. So let's say after a while, and who knows how many times, like I said, now you might, it's not just 5 and 3, 3 comma 5, that's a totally different answer that was possible. And of course I don't even need to run through the motions there. 3 comma 5 is also not going to work out for the second equation, okay? But 2 comma 6, I'm pretty sure, I'm doing this a day later, but I'm pretty sure that was, and so here we go, that was 6, and that's 30, and when you add them up, you do get 36, so that kind of checks out as well. And so it turns out that this solves both this equation and this equation, and therefore 2 comma 6 is the answer, okay? So there it is. And the only other thing I want to say is you were supposed to show or explain all of your work, and it's tough to tell sometimes if by also showing, for example, that if you plug in 2 for x and 6 for y, and that it's going to equal 8, and actually writing out, and again, being as thorough as possible, 8 equals 8, and actually writing out from the second equation that 6 plus 30 equals 36, and that is 36, and 36 does equal 36. I mean, if you're going to show, if you want to show all your work, then you got to be really, really thorough if you can. But I don't know. I don't know if you'd also need to explain that you were just kind of trying out different ordered pairs to see, that you were going to just try to find an ordered pair that would solve or satisfy both equations. I don't know. Better to be safe than sorry. Better to be overly thorough with your showing and your explaining than to risk whoever's grading your Keystone exam be like, well, this person didn't show enough work, or they were supposed to explain that they were just randomly plugging in values for x and y until they figured out an ordered pair that solved both. So anyway, sorry for the jumbled mess, but that would be the guessing and checking method.